Hey guys, so today we're gonna do a quick little review on solving multi-step equations. First thing I want to talk about is this acronym, DCMAM. You can think of it as don't call me after midnight. These are steps to help us solve multi-step equations. So mathematically, D stands for distribute. So usually when we see parentheses, or very rarely in lower level math, you'll have some brackets. Then the C stands for combine like terms. So these are things with the same number or the same letter, or in other words, variable. Then we have M. Now our first step is going to be to move the smaller variable. Move the smaller variable, and you're moving it to the other side of the equation. Then A is going to be add or subtract. You're basically just trying to isolate. Around this point, it's usually a two-step equation or even a one-step. You don't always have to use all the letters. So this will be add or subtract. And then lastly, the M, multiply or divide. And I want to emphasize you're not always going to use every single letter. You just have to use them in this order, whichever ones you use. This is the most helpful and direct way to solve a multi-step equation. This even works for one and two-step equations. It's just you'd only use the last two letters. So here's an example of a multi-step equation. First thing I'm going to do, just like with one and two-step equations, I'm going to draw a line just to visually separate the two sides. So starting with that first letter D. D stands to distribute. Well, can I distribute? I have parentheses with a number in front. That means I can. So I have to distribute this 4 into everything inside the parentheses. Now distribute is just multiplication, so that's all we're doing. 4 times x is 4x. 4 times 3 is 12. Everything else not part of that, you're going to copy or bring down. So this minus 2, I'm bringing it down, the equal, and the 6. Now we go to C, combine like terms. So these are terms which are just these different numbers and letters that you see, these different groupings. Anything that has the same variable or doesn't have a variable. This is the only x, so there's no other like term that I can use, so I can't combine this one. However, 12, negative 2, I can combine those. This is the same as 12 minus 2, so this becomes a 10. I don't combine it with the 6, even though they are like terms, right? They both don't have a variable because it's on the other side. This guy means combine like terms on the same side of the equation. Anything else I'm not counting, copy it down. Next I have M, move the smaller variable. However, there's only one variable. So this is an example where I'm not going to use every letter. There's only one variable, I can't move it anywhere, right? There's nowhere to combine it with. Next, add or subtract. Well, I want the x by himself. We know when we are trying to isolate something, anything that's not grouped with that variable comes first. So 10 is not touching my x. I need to get rid of him to be able to enter into this group. So since we're adding, the opposite is to subtract. When I subtract, it cancels it out on this side. So I'm left with just the 4x. And here I have 6 minus 10, which is a negative 4. And then my last step, multiply or divide. I'm multiplying the x by 4, so the opposite is to divide it. And we're left with x is equal to negative 1. As you can see, we didn't have to use every letter to solve it, but we did use the same order, right? I went in the order that was written. So here's another example. Again, we might not go through all the letters, but I wanted to give you an example where we were moving the variable so you see what that looks like. So you know you're going to have to do that when there is a variable on both sides. Now let's start with our first one, D. Am I distributing? Well, there's no parentheses, no brackets, so there's no distributing going on. Next, combine like terms. On this side, because remember it's on the same side, on this side I have a term with the variable and a term without. I can't combine them. I go to the other side and the same thing is happening. So if I look at each side separately, I cannot combine anything. So we're skipping C, going straight to moving the smaller variable. So by smaller, we mean the smaller coefficient, which is the number in front of the variable. So my options are 3 and that invisible 1. Well, out of the numbers 1 and 3, 1 is smaller, so I'm going to move it to the other side. And that's why I'm going to combine those variables to be 1. Now to do this, it's kind of like canceling it out. I do the opposite. So over here, it's a positive 1x, so I have to subtract x, or subtract 1x. That's going to cancel it out. Now, when I subtract it here, I subtract it to the term that has the same variable. That's what makes them alike. 3x minus 1x is 2x. Everything else, so pretty much everything that doesn't have an x, we're going to bring down. Plus 3 equals and 5. Now from here, I have A, add or subtract. Well, here's my x, right? The one not touching x, that plus 3 is the one that's got to go first. Since it's a plus, the opposite is to minus. And we're going to bring everything down. And our last step, which tends to be the same last step, is to divide, right? Multiply or divide. And remember, when I draw a line to cancel them out, that doesn't mean that it's always 0. It can be a 1. All that matters is that I'm realizing or recognizing that this 1 here is normally not written. So if putting that line confuses you, you don't have to do it. That's just how you're going to see most work written. Now, one last thing I want to talk about is moving the smaller variable when there's negatives. So as an example, if I were to have something like this, and you're trying to figure out which one do I move? Do we move the -2 or the -4? Now, most of us know the number 2 is smaller than the number 4, but with negatives, it's actually opposite. The less negative, or the smaller number, if you took off the minus, is actually bigger. -4 is more negative than -2. Think of it like money. Would you rather owe $2 or owe $4? I think we can all agree owing 4 is worse, right? That's a bigger debt. So that makes it smaller, right? That's less than you have. I'd rather be missing 2 than missing 4. This is worse. It's more negative, it's smaller, it's less. So we would be moving that -4x. Now, since it's a negative, the opposite would be to add it to both sides. You know you did this step right whenever you finish it, you get a positive. So -2x plus 4x is positive 2x. If when you do that first m, you still have a negative, it's very likely that you did not do this correctly. So just keep that in mind. That's kind of the whole point, is to make your numbers a little friendlier. And that's pretty much it for solving multi-step equations.